The morning of March 11th, 1943, at the sprawling Lockheed plant in Burbank, California, the smell of hot oil and burning fuel clung to every corner of Hangar Four. Beneath the twin tails of a partially assembled P-38 Lightning, Sergeant William Bill Johnson, a maintenance mechanic assigned to the 7th Air Service Command, crouched over the right engine nacelle, his hands streaked with black grease. Around him, other men tightened bolts, adjusted fuel lines, and polished propellers until the polished aluminum reflected the high California sun. But Johnson was not performing routine maintenance. He was preparing to test a modification he had designed himself. A new supercharger gear assembly he believed could allow the P-38 to climb to 30,000 feet, far above the operational envelope pilots had been told was safe. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. For months, mechanics and engineers had debated the limits of the Allison V1710 engines, twin 12-cylinder marvels that powered the Lightning with unprecedented speed and reliability. Standard doctrine held that the P-38's turbo superchargers, mounted in the rear of each engine nacelle, could maintain full power only up to 25,000 feet. Any attempt beyond that altitude risked catastrophic detonation or structural failure. The manuals, written by engineers at Lockheed and Allison Aircraft, were unequivocal. Test pilots were instructed to avoid sustained operations above that ceiling. Yet Johnson, a 29-year-old ex-airplane mechanic from Wichita, Kansas, had been poring over high-altitude flight reports, listening to pilots' complaints about turbo lag, and noticing small inconsistencies in the pressure valves that controlled the supercharger gear ratios. "I don't care what the engineers say," he had muttered to his fellow crew chief one night, leaning over the schematic of the engine. "We can make this climb higher. The engine has the torque. The problem is the gear ratio in the supercharger. It chokes too early. If we adjust it, we can take the plane into the stratosphere." It was a dangerous gamble. Any miscalculation, and the Lightning's engine would explode in the thin, freezing air above 28,000 feet. Johnson knew that, but his quiet obsession with precision and performance outweighed fear. In the end, his commander had reluctantly allowed the experiment, framing it as a limited test under controlled conditions, though both men knew that above all, it was a test of faith. Faith in the pilot, faith in the plane, and faith in a mechanic's judgment over established doctrine. The P-38 rolled off the assembly line and onto the runway, engines humming with low-frequency vibration. Captain Thomas "Tommy" Hayes, a seasoned test pilot with the 39th Fighter Squadron, climbed into the cockpit, strapping himself into the leather harness. The altimeter dial gleamed in the morning light, 25,000 feet marked in red, a psychological limit as much as a mechanical one. Johnson's modification had been applied to only one aircraft, the prototype, serial number 49321. The crew circled the plane, checking control surfaces, verifying fuel flow, and confirming ignition timing. When Hayes throttled forward, the twin Allison engines roared, and the P-38 lurched forward like a predator sensing open sky. The hangar crew stepped back, shading their eyes as the nose lifted and the aircraft began its climb. In those first 1,000 feet, everything appeared normal, vibrations minimal, temperature readings steady, and turbo boost gauges within expected parameters. Then the Lightning passed 20,000 feet, approaching the altitude that previous manuals had claimed was the absolute operational ceiling. The supercharger whined, but the new gear ratio worked perfectly. The boost increased steadily, allowing full throttle without engine knock. Above 25,000 feet, the thin air began to bite. The cabin pressurization, minimal by design, could not compensate fully, and condensation formed on the canopy edges. Hayes adjusted oxygen flow and leaned into the controls. He felt the subtle increase in responsiveness as the propellers sliced through the rarefied air with less drag. By 28,000 feet, the aircraft was beyond the limits anyone had dared to maintain in routine flight. Johnson's Supercharger mod had worked. As the P-38 pierced 29,000 feet, Hayes looked down at the horizon. The world below was a patchwork of hazy smog and the distant Pacific, and he felt a mix of exhilaration and unease. Every climb past the prescribed ceiling increased risk. If the engine failed now, there would be no room to recover. Yet the plane was solid, the vibrations predictable, the response precise. At 30,000 feet, Hayes's altimeter ticked over, and he let out a slow, steady breath into his oxygen mask. He radioed Johnson. "Bill, she's holding steady at 30,000. Repeat, 30,000 feet. No knock, no lag." On the ground, Johnson and the hangar crew erupted into quiet disbelief. They had witnessed a lightning ascend to altitudes that were previously theoretical, possible only on paper. The dangerous modification, scorned by engineers as reckless, had turned the P-38 into a new type of fighter, one capable of engaging enemy aircraft far above their operational ceiling, opening a vertical battlefield that no Japanese pilot had yet imagined. The psychological implications were immediate. American pilots, long aware of the Zero's dominance at low to medium altitudes, now had the potential to dictate engagements from heights previously denied to them. The Zero, unmatched in turning agility below 20,000 feet, could not pursue a lightning diving from 30,000 feet without exceeding structural limits. Japanese air doctrine, which emphasized horizontal maneuvering and dogfighting skill, was suddenly obsolete in the face of vertical dominance. A single P-38 with the Supercharger modification could climb beyond the enemy's reach, strike, and disappear before retaliation was possible. Johnson, who had once been just another mechanic in a vast industrial complex, suddenly understood the scope of what he had achieved. In quiet moments, he would later reflect on that day, that the success was not in raw speed, or in firepower, or even in pilot skill alone, but in the unseen gears, in the minute adjustments to the engine's heart, that transformed the Lightning from a fast fighter into a machine that could dominate the vertical dimension of air combat. The first operational Lightning equipped with Johnson's mod would be delivered to the Pacific Theatre in April 1943. Pilots who climbed into the cockpit were briefed not only on flight procedures, but also on the hidden potential they now carried. A climb to 30,000 feet, where enemy fighters could not follow, where the sun glinted off aluminum wings above the clouds, and where life and death decisions were made in a realm few men had ever imagined. In letters sent back to families, some pilots spoke of the heavenly perch they now commanded, a subtle acknowledgement of the profound advantage the modification provided. The story of Johnson's Supercharger mod would ripple through the ranks quietly at first. Reports from reconnaissance missions indicated that Japanese formations were beginning to encounter American fighters from altitudes that made their traditional tactics ineffective. Letters intercepted from Japanese pilots described confusion, frustration, and fear of an unseen enemy striking from above. It was a slow erosion of confidence, psychological as much as tactical, the seeds of a shift that would eventually redefine air combat in the Pacific. By late April 1943, the first operational P-38 Lightnings outfitted with Johnson's Supercharger modification had arrived at Henderson Field, Guadalcanal. The airfield, scarred by months of continuous bombardment and hastily repaired runways, was a far cry from the orderly hangars of Burbank. Ground crews worked under the relentless tropical sun, repairing bomb damage, clearing debris, and readying the new Lightnings for their first combat sorties. Captain Thomas Hayes, now assigned to the 39th Fighter Squadron, climbed into one of the modified aircraft. He had flown the test flights himself, yet the prospect of encountering Japanese fighters in combat at 30,000 feet was entirely different from the controlled ascents over California. Intelligence briefings were cautious. Japanese Zeros were still dominant at lower altitudes, but reports hinted at strange sightings of twin-engine aircraft diving from above. No one yet knew the full impact Johnson's modification could have. The mission on April 22, 1943, was routine in form but unprecedented in potential. A formation of 8 P-38 seconds escorted 4 Boeing B-17 Flying Fortresses on a reconnaissance run over the northern Solomons. The mission plan adhered to standard doctrine: maintain formation, cover the bombers, engage enemy fighters if necessary. Yet the vertical advantage the Lightnings now possessed, allowed Hayes and his flight to consider tactics previously unthinkable. At 25,000 feet, over the clouds and just above the Japanese operational ceiling, Hayes climbed slightly higher. The sun glinted off the polished fuselage of the Lightning, and below, the dense Pacific jungles stretched toward the horizon. Japanese aircraft soon appeared a mixed formation of Mitsubishi A6M0s and Nakajima Ki-43 Oscars, approaching at medium altitude, unaware that American fighters now held the unseen high ground. Hayes adjusted throttle and prop pitch, initiating a steep climb. The modified Supercharger engaged seamlessly, delivering consistent boost despite the thinning air. The Lightning accelerated past 28,000 feet, then 30,000, holding steady as the Japanese formation remained below, struggling to anticipate the engagement. From that perch, the tactics were simple yet devastating. Hayes signaled the attack: dive from altitude, concentrate fire from the nose-mounted 20mm Hispano cannon and 50 caliber Browning machine guns, then pull up and return to high altitude before the enemy could respond. The Japanese pilots, trained in horizontal dogfighting, were unprepared for a three-dimensional assault. Zeros attempted to climb, but their engines lost power as they reached 20,000 feet. Their climb rate, never a strong suit at high altitude, could not match the velocity and vertical maneuverability of the Lightning. Lieutenant Richard Bong, temporarily attached to the squadron for combat familiarization, engaged his first target at 29,000 feet. He described the encounter later in a debriefing. The Zero seemed to vanish into the clouds below me, and then, with a rush, I was on its tail before it could even respond. One burst from the nose cannon, and the aircraft was in flames. I pulled up, re-engaged altitude, and it was as though it had never been there. The Japanese had no answer for this kind of engagement. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The engagement lasted under 10 minutes, yet it demonstrated a profound tactical shift. Traditional Allied air doctrine emphasized turning engagements at low altitude, often with numerical superiority as a compensating factor. Now, the P-38 seconds could fight on their own terms, exploiting a combination of altitude, speed, and concentrated firepower. The vertical battlefield had replaced the horizontal one, and the Japanese pilots' mastery of maneuvering combat was suddenly insufficient. Mechanically, the modification worked because Johnson had altered the Supercharger's high-gear ratio, delaying the point at which the turbocharger would reach its maximum rotational speed. By doing so, the Allison engines maintained full manifold pressure at altitudes previously considered unsafe. The increased airflow through the carburetor and enhanced compression allowed the engine to deliver consistent horsepower up to 30,000 feet. The key was precision. One miscalculation in valve timing or gear alignment could have resulted in catastrophic detonation. The fact that the modification held in actual combat conditions was a testament not only to Johnson's skill, but to the rigorous testing procedures he had devised. Psychologically, the effect was just as significant. Japanese pilots, trained for superiority in dogfighting at altitudes below 20,000 feet, faced an enemy that now dictated the terms of engagement. Letters recovered from Imperial Japanese Navy squadrons described the Ghost fighters aircraft that appeared seemingly from nowhere, struck with deadly force, and vanished into the upper atmosphere. The cumulative effect on morale was profound. Senior pilots who had dominated the Pacific skies now hesitated, reassessing risk in a theater where altitude determined survival more than maneuverability. In subsequent sorties throughout May 1943, the advantages of the modified P-38 became undeniable. On May 7th, a patrol over Bougainville encountered a large Japanese formation escorting bombers. Hayes led his flight to 30,000 feet, while a second flight of Lightnings maintained escort below. From the upper altitude, Hayes executed a series of diving attacks, claiming 3 enemy aircraft while sustaining no losses. Observers on the ground reported that Japanese pilots attempted to follow, but their aircraft shuddered under the strain of high-speed climbs, exceeding their design limitations. The effectiveness of the modification also accelerated changes in Allied tactics. Squadron leaders instituted strict altitude discipline. Pilots were trained to climb first, engage second. Fuel management, previously a secondary concern, became central. Johnson's modifications allowed for sustained high-altitude operations, but each climb consumed additional fuel. Pilots learned to balance the psychological advantage of altitude with the practical necessity of returning safely. In a series of memos circulated among Pacific fighter groups, commanders emphasized that altitude is life insurance, a principle born directly from the Supercharger mod's impact. Johnson himself was transferred to the Pacific Theater in late May, a rare honor for a mechanic. His role was advisory, ensuring that the modifications were applied correctly, troubleshooting mechanical issues in theater, and providing technical instruction to pilots. He became, unofficially, the guardian of the Lightning's new vertical dominance. Pilots respected him for his insight and, perhaps more importantly, for taking responsibility for an innovation that had directly saved lives in combat. By June 1943, the ripple effects were clear in Japanese after-action reports. Intercepted communications described formations being attacked from above, unable to reach the enemy, and pilots experiencing unprecedented stress. The concept of dogfighting mastery, previously central to their training and cultural ethos, was being undermined by a mechanical innovation. Strategically, it contributed to a shift in air superiority. The Japanese could no longer assume control at any given altitude, and American pilots began to exploit the vertical dimension systematically. Industrial capacity amplified. The impact. Lockheed's Burbank facility, along with production at the Vega subsidiary in Oklahoma, ramped up output of P-38 seconds with Johnson's modifications. By July 1943, squadrons across the South Pacific were flying Lightnings capable of sustained operations at altitudes above 28,000 feet. Every new deployment reinforced the psychological and tactical advantage. Japanese pilots, encountering P-38 seconds on multiple fronts, had to adapt quickly or face annihilation. The broader significance of Johnson's work became apparent in subsequent operations. During the Battle of the Bismarck Sea in March 1944, Lightnings escorted bombers at altitudes previously unattainable, enabling near-total destruction of Japanese shipping and air cover. While other factors, intelligence, coordination with bombers, and superior firepower contributed, the vertical advantage facilitated by Johnson's modification allowed pilots to engage enemy fighters decisively and from positions the Japanese could not counter. The irony was profound. A mechanic, initially dismissed as reckless, had altered the trajectory of aerial combat through a subtle yet precise engineering intervention. Pilots who had long feared the Zero now commanded a vantage that their enemy could neither reach nor counter effectively. Tactical manuals would eventually be rewritten to incorporate the lessons learned: altitude supremacy, turbocharger optimization, and vertical maneuvering as central tenets of air combat strategy. The story of William Johnson and his dangerous supercharger mod illustrates the convergence of human ingenuity, mechanical precision, and psychological impact. In the vast machinery of war, individual initiative often seems inconsequential, yet in this instance, it changed the calculus of life and death in the Pacific skies. The P-38's legacy, long celebrated for speed and firepower, owed an equal debt to the unseen hands of the mechanic, who dared to trust calculations over doctrine, intuition over caution, and meticulous craft over convention. As Johnson would later write in his personal notes, preserved in the archives of the National Air and Space Museum, "Machines obey the laws of physics, not manuals. If you understand the machine, you can do more than the papers say. I only made the plane do what it was already capable of, I just let it show the world." By the summer of 1943, pilots throughout the Pacific were flying higher than any human combatants had dared. Zeros, once masters of the skies, now struggled to intercept a phantom threat from the stratosphere. The vertical battlefield had been opened, and it was Bill Johnson's modification, quiet and meticulous, that had cracked the ceiling of possibility. By August 1943, the impact of Johnson's supercharger modification had become an operational reality across the South Pacific. Pilots who had once feared the agility of Japanese Zeros were now routinely engaging enemy formations from altitudes that had previously been inconceivable. The vertical battlefield had shifted the psychological calculus of combat. Zeros could no longer dictate the tempo of engagements. The Lightning's new ceiling allowed American pilots to choose when and where to strike, reducing risk while maximizing lethality. Captain Hayes, now a squadron commander, recounted one such engagement over the Solomon Islands. "We climbed to 29,000 feet before even spotting them. By the time the Zeros tried to follow, we were already diving. They couldn't keep up. It was like shooting fish in a barrel, except you were above the water. The plane held steady. The engines didn't falter. Bill's modification made us untouchable from the sky." These first-hand accounts underscore a profound irony. American doctrine and training had long emphasized tactical discipline, formation flying, and firepower. But the ability to dominate the vertical axis had rested entirely on one mechanic's insight. The established engineering manuals and test pilots' limitations had defined what was safe, but Johnson's meticulous adjustment of the Supercharger had expanded the Lightning's operational envelope in ways no one in the formal hierarchy had anticipated. The Japanese response, when it came, was tactical adaptation under duress. Intercepting P-38 seconds required greater numbers, coordinated climbing attacks, and an emphasis on early detection to offset the Americans' altitude advantage. Yet, despite these efforts, reports from Rabaul indicated frustration and fatigue among pilots. In personal letters and squadron logs, phrases like "cannot reach," "fighting a ghost from above," and "climbing to heights we cannot follow" appear repeatedly. The psychological impact was unmistakable. Pilots trained to dominate the skies now confronted an invisible enemy operating on a plane of existence, beyond their reach. From a mechanical perspective, the modification's success was remarkable. Allison V 1000, 710 engines, each producing 1,150 horsepower, were now operating at altitudes where, without the adjustment, output would have dropped significantly. Turbo supercharger ratios had been optimized for higher manifold pressure at extreme altitude, a feat of precision engineering that required exact tolerances and impeccable timing. Even minor errors in gear alignment or valve calibration would have risked engine detonation, yet Johnson's meticulous craftsmanship ensured consistent performance. For the first time, the Lightning could sustain high-altitude operations long enough to affect the strategic calculus of engagements. The operational consequences were felt most sharply during the missions supporting the invasion of New Guinea and later the Central Solomons campaigns. Pilots in modified P-38 seconds provided top cover for bombers, conducted reconnaissance, and executed dive attacks that Japanese pilots were ill-equipped to counter. In one documented encounter in November 1943, a squadron of 6 modified Lightnings engaged 15 Zeros escorting bombers. Within minutes, the Americans destroyed 4 enemy fighters and damaged several others, without losing a single aircraft. The vertical advantage, the ability to dive from 30,000 feet, proved decisive. Mechanics like Johnson became unsung heroes of the air war. While pilots received accolades, medals, and recognition, the men who labored in the hangars, turning schematics into life-saving innovations, often remained in the shadows. Johnson, however, received a quiet acknowledgement from squadron commanders and engineers, a commendation noting exceptional technical ingenuity in the improvement of Allison V 1000, 710 engines for operational high-altitude performance. It was modest, yet it reflected an understanding of the magnitude of his contribution. The broader historical significance of the modification extended beyond individual engagements. By opening the vertical battlefield, Johnson had changed the nature of air superiority in the Pacific. Where Zeros had once dominated through maneuverability and pilot skill, the P-38 now leveraged mechanical innovation to redefine the terms of combat. Doctrine evolved. High-altitude interception, energy management, and dive and climb tactics became central to American fighter operations. Manuals were rewritten to include Johnson's Supercharger specifications, and future generations of P-38 pilots were trained to exploit the extreme ceiling the modification allowed. Reflecting on the legacy decades later, historians have emphasized the intertwined nature of human ingenuity and mechanical precision. The Lightning's twin Allison engines, the carefully designed airframe, and Johnson's modification converged to create a force multiplier far exceeding the sum of its parts. One mechanic's intervention, executed with meticulous care and an understanding of physics, altered the course of engagements and, in subtle but profound ways, influenced the strategic momentum of the Pacific theater. In personal reflections, Johnson described the experience not in terms of glory, but in terms of responsibility. "I wasn't trying to make history. I was trying to make the machine work the way it was supposed to. But when you see the pilot climbing above the clouds, watching him maneuver, and you realize that a small adjustment you made is keeping him alive, it changes your understanding of what a job is. You're not just turning wrenches, you're shaping outcomes." The story of the P-38's high-altitude capabilities also illuminates a broader historical truth about technological adaptation in war. Often, the decisive innovations are not grand strategies or battlefield heroics, but the precise adjustments, the insights that allow machines and men to perform beyond their expected limits. Johnson's work exemplified this principle. The combination of mechanical skill, empirical observation, and disciplined courage created an advantage that doctrine alone could not provide. By the end of 1943, the P-38's reputation for high-altitude dominance was firmly established. Pilots across the Pacific had learned to respect the Lightning not just for its firepower or speed, but for the altitude it could hold, the freedom it granted them to dictate engagements, and the unseen hand of innovation that made it possible. Japanese pilots, encountering these aircraft repeatedly, adjusted their tactics, but could not fully neutralize the vertical advantage. The modification did not win the war on its own, but it tilted the air war in favor of American forces in a way that was immediate, measurable, and psychologically profound. The final irony of the story is subtle but significant. In a war defined by mass industrial production, grand strategies, and vast fleets, a single mechanic in a California hangar altered the operational potential of a fighter plane in ways that no manual, memo, or doctrine had anticipated. The P-38 seconds that climbed above 30,000 feet owed their ability not just to design or engineering specifications, but to human insight, care, and the willingness to challenge established limits. In the end, the story of Bill Johnson and his dangerous Supercharger modification is more than a tale of engineering triumph. It is a reflection on the intersection of human ingenuity and war, the ways in which careful observation and precise action can amplify the effectiveness of technology, and the subtle but profound ways in which individual initiative shapes history. The P-38 Lightnings that soared above the Solomons, untouchable to the Zeros below, were as much a testament to the quiet genius of a mechanic as they were to the pilots who flew them. Through letters, squadron reports, and pilot memoirs, the legacy of that modification endures. The story of a machine, a mechanic, and a sky that suddenly became larger, higher, and more dangerous for those who had once ruled it. And in the reflection of polished aluminum under the tropical sun, one can still imagine Johnson crouched in the hangar, hands black with grease, turning a gear that changed the course of the air war in the Pacific. The war in the Pacific continued to rage through 1944, yet by then, the P-38 Lightnings carrying Johnson's Supercharger modification had become a symbol of American ingenuity in the air. Pilots who had once learned to fear the Zero now spoke in hushed tones of the heavenly perch, a vantage point above the clouds from which life and death decisions could be made with calm precision. The altitude advantage was not just technical, it was psychological. Airmen reported a strange confidence when climbing above 28,000 feet, knowing that enemy fighters could neither follow nor challenge them effectively. Johnson, who had remained in the Pacific theater as a technical advisor, watched this transformation with a quiet pride. He spent hours inspecting engines, recalibrating superchargers, and training mechanics to reproduce his modifications consistently. Unlike the pilots who received medals and public recognition, Johnson's contribution was subtle, almost invisible, yet indispensable. He understood that in war, sometimes survival and sometimes victory depends on the unseen hands that ensure the machinery functions beyond expectation. The human element of this story is inseparable from the technical achievement. Pilots, mechanics, and engineers formed an ecosystem in which innovation could thrive. Johnson had relied on meticulous observation, years of hands-on experience, and careful calculation, but without courageous pilots like Captain Hayes and Lieutenant Bong, his modification would have remained an experiment. The interplay between human ingenuity and mechanical capability defined the effectiveness of the P-38 seconds in combat. By mid-1944, the operational impact of the Supercharger modification was clear. Japanese intelligence, despite diligent observation and technical analysis, could not fully counter the high-altitude attacks. Zeros, trained in low to mid-altitude maneuvering, were increasingly vulnerable. Letters intercepted from Japanese pilots described frustration and confusion, sometimes bordering on disbelief. One squadron log, later captured by Allied forces, described an encounter over New Guinea. "The enemy climbs to heights we cannot reach. Our aircraft shudder, engines overstrained, and still they descend upon us like shadows from above. We can maneuver, but they are gone before we can retaliate. These are no ordinary fighters, something has changed." These words illustrate the subtle yet profound psychological shift. Combat effectiveness is rarely determined by machines alone. Perception, confidence, and morale play decisive roles. The P-38's altitude advantage created a psychological asymmetry that amplified its tactical effectiveness. Japanese pilots faced an enemy that not only outperformed them mechanically, but also operated in a dimension that rendered their training partially obsolete. Johnson's modification also influenced Allied doctrine beyond the Pacific. Tactical manuals were revised to include high-altitude maneuvers, energy management, and the strategic use of turbocharged engines. Pilots were trained to climb aggressively, strike from altitude, and retreat before being engaged. These lessons would echo into the development of subsequent fighter aircraft, where vertical performance became a critical design consideration. The story of one mechanic's insight thus rippled through industrial, tactical, and operational levels of the Allied air war. In personal reflection, Johnson later described the moral complexity of his contribution. War demanded innovation, yet innovation always carried risk. Each time a P-38 climbed above 28,000 feet, he understood that a mechanical failure could cost lives instantly. Yet the same modification that threatened disaster also saved lives and altered the course of air engagements. In letters to his family, he wrote, "You build machines to obey the laws of physics. You adjust, calibrate, test, and hope that your judgment is right. I never thought about fame or glory, only that if it works, it keeps our boys alive. That is enough." This humility contrasts sharply with the scale of impact. The modification did not merely improve performance, it redefined the battlefield, reshaped tactics, and contributed materially to air superiority in the South Pacific. In engagements across the Solomon Islands, New Guinea, and later the Philippines, pilots exploited the altitude advantage to intercept enemy formations, protect bombers, and engage fighters on favorable terms. The combination of mechanical innovation and pilot skill turned what might have been incremental improvements into decisive operational advantage. The narrative also highlights a broader historical truth. In war, innovation often comes from unexpected sources. Johnson was neither a senior engineer nor a test pilot. He was a skilled mechanic, observant, meticulous, and willing to challenge conventional limits. His success underscores the importance of individual initiative within large, hierarchical organizations. Doctrine, manuals, and engineering specifications define boundaries, but ingenuity can extend them, sometimes dramatically altering outcomes. By 1945, the Pacific Air War had evolved, and the P-38 had earned its place as one of the most versatile and effective fighters of World War II. High-altitude operations, made possible by Johnson's modification, allowed the Allies to exploit an advantage that was as much psychological as mechanical. The story of the modification became part of the broader history of the aircraft, a reminder that sometimes the difference between life and death, between victory and defeat, lies in small, precise, and often invisible acts of human skill. As the war drew to a close, Johnson returned to civilian life, largely unknown to the public. He continued to work on aircraft, applying the same principles of careful observation and technical ingenuity to peacetime aviation. Pilots who had flown the modified P-38 seconds remembered him as a quiet hero, a man whose work in the shadows allowed them to dominate the skies and return safely. Reflecting decades later, historians have emphasized the confluence of factors that made the modification consequential. The P-38's airframe, the Allison engines, the twin turbochargers, the pilot's skill, and Johnson's precise intervention all combined to create a machine capable of exceeding established operational limits. This synergy between human initiative and technological potential offers a lesson that extends beyond military history. Even within massive systems, individual insight, when applied with skill and precision, can generate outcomes that reshape entire theaters of operation. The final irony of the story is its quietness. In a war defined by strategy, propaganda, and massive industrial output, it was a mechanic's subtle recalibration of a single system that altered the operational reality of the Pacific Air War. Johnson's achievement did not produce headlines, but it produced results. Pilots climbed higher, survived longer, and struck more decisively. The invisible hand of ingenuity had created an edge that was tangible, deadly, and enduring. In the annals of aviation history, the story endures as a testament to the power of meticulous observation and deliberate action. The P-38 seconds that soared above 30,000 feet, untouchable by their adversaries, carried the imprint of human creativity as much as the legacy of engineering. And, in the memory of those who flew, maintained, and depended on them, one mechanic's hands, blackened with grease and steady in purpose, remain a quiet symbol of the difference one individual can make, even amid the chaos of global war. Ultimately, the story of the Supercharger modification is a reflection on trust, precision, and vision. It reminds us that in war, as in life, careful attention to detail, courage to act beyond conventional limits, and the insight to see possibilities where others see boundaries can leave a mark far greater than the sum of its parts. Bill Johnson's legacy, hidden in the mechanics of a fighter plane, reshaped the Pacific skies and, in doing so, illuminated the profound ways human skill and ingenuity can shape history. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.